we're going to look at some financial problems. Investing money by regular installments. There's these things called annuities. Now, basically it's a compound interest investment, and payments are made or received on a regular basis. There's two different types. There's what we call an ordinary annuity. These are ones where you deposit the same amount at the end of the compounding period. So that's a loan, and you might think, hang on, a loan is an investment? Well, it is. It's sort of like a reverse investment. It's like the bank is investing in you instead of you investing in the bank. So we still think of it like an investment, but we pay them the money at the end of the compounding period. Because obviously if you take out a loan, you say, well, thanks for the money. Oh, by the way, here's the first repayment. I mean, that would just be silly. You do it at the end of the compounding period. So that's what we call an ordinary annuity. And then there's annuity due. If you think about it, the term's sort of the backwards way around, because you think, oh, if it's due, then I owe you something. But no, annuity due is when you deposit the same amount at the beginning of each compounding period. And so here's when you're investing in the bank. And that's why you would do it at the start. So it's in there for a certain time period, and then you get some interest. Future value. That's the total value of the investment at the end. So what will it be worth in the future? And then present value is this one. If instead of going, okay, I'm going to, let's say it's monthly, I'm going to put money in every month and it will compound and eventually it would get to some future value. Well, if instead of doing that, how about I just put one lump sum in now? How much would I have to put in now to get that same amount in that many years' time? So that's what we call present value. How much could I put in now to get that same future value? Annuities. There is a financial product out there called an annuity. And yes, it's a type of annuity, but it's not the only type. Okay, so don't get confused that annuity is just this one thing. So different types of annuities. Let's first of all look at annuity due, so the investment type. HSC question, it's a very simplified problem, because the reality of superannuation is whilst you put in the same amount, the interest you get back is not the same every time period, because they'll go and put your money in different investments, and obviously depending on how the market's going and what sort of return you're going to get on that investment. So it's very simplified here, where we're assuming that we're always going to get 8.75% per annum, and it's going to compound annually. We're going to put in, or Stephanie's going to put in, $5,000 into the fund at the beginning of each year, commencing on the 1st of January 2003. So what will be the value of this superannuation when she eventually retires 20 years later? Oh, she just retired. Look at that, 31st of December 2023. So that initial one that she put in, that's going to be in there for 21 years. That compound interest formula, that initial investment will be worth that amount. But then the next year she'll put another one in, but that'll only be in there for 20 years. And then every year she'll put one in, so the next one will be in there for 19 years, and we keep going and we keep going until the one she puts in at the start of 2023, and that'll just be in there for 1 year. So her total investment will be all of those things added together. Okay. Well, we've got a geometric series here. The first term, I'm actually reading it backwards, so the first term is 5,000 times 1.0875, the ratio is 1.0875, and the number of investments we made, well, there were 21 of them. So we can just substitute it into our sum formula. Sum of 21, and that all turns out to be, there we go, $299,604. I've asterisked this because this wasn't actually part of the HSC question, I just added it in. But find the year when the fund first exceeds $200,000. When did it first exceed that? So now, this time, I don't know what the last investment, how long it was in there for, because I want to know. When did it first go over? What was that time period? So that will equal the sum to the end, but the difference now is we're saying, hey, I know the amount I want this to be, so it's got to be greater than 200,000. I just use my geometric series formula, but now I don't know n, so that's in there, but I want it to be greater than 200,000. Rearranging all that, we get a log situation. I've got to bring the n to the front, divide by the log, but this one's a positive one because it's more than one, and we get 17.1. So n would be 18, because it's got to be bigger than that. 2021 is when it first exceeded the 200,000 mark. Well, everyone would like $1 million. It's one of those figures everyone goes, oh, I've got $1 million. So how much would I have to put in to get $1 million? This time I don't know the P, the principal, because I'm trying to work out how much am I going to put in. But it'll be a series again, but this time the highest one would be 18. And so there's our geometric series. We want the sum to be $1 million. That's what we would like. Let's now just play around with this equation. Make P the subject, and there it is. If you could afford to do it, then if each year you put in $22,818, then you would get $1 million in 20 years' time. So working out the future value of this thing. So the future value is that final amount. PR would be the last investment, PR squared would be the second last investment, all the way up to PRN, which would be the first investment that we made, which is a geometric series. So really, this could be a formula to work out future value. P, R, Rn minus 1 over R minus 1. P, of course, is the principal, R is our interest rate, N is the time periods. So now let's go back to Stephanie. If she could afford it, how much money could she save by making one investment and still have that same future value in 21 years' time? So in other words, we want to work out the present value. How much would I put in now, right at the start, and still get the same amount of money, which we worked out, remember, was $299,604.86. Okay, well, we just do a division. There it is, 54,000. So if she had a spare let's say $55,000 lying around, put it in now and just forget about it for 20 years, she'll get the same amount of money. Okay, but that's not what the question asks. How much money could she save? What did she invest? Remember, every year she was putting in $5,000. She was doing that for 21 years. So she actually invested $105,000. So the saving obviously is the difference. She could have saved herself, $50,500 by doing it that way, if she happened to have that amount lying around. So the present value then of an annuity due, what we're saying then is it's this one investment and we're going to put it in at the start and it will equal the future value. And we came up with a formula for future value. So if I rearrange this, I can get a formula for present value. So present value, PR, 1 minus R to the negative N over R minus 1. Okay, P is the principal, 1 plus the interest rate, and so on. Now sometimes they might just give us a table to look up to save all the calculations. So here's one where, and it's just for $1, but then obviously you multiply it by however many dollars you're investing in. So we've got these two people, Tim and Janine, and they're offered interest of 6% per annum for 4 years. Tim decides to invest $1,500 each quarter, so then it'll be compounded quarterly. And Janine said, no, I'm going to do it $500 each month, compounded monthly. So who's going to get the most interest? So Tim is 6% per annum. He's going to do it at 1.5% per quarter. So we look at the 1.5% column, but how many quarters? Well, it's 4 years, so that's 16 quarters. So we get 17.9324 off our table, but that was for $1. Multiply by 1,500, we get our amount. Janine, her 6%, but she's doing it monthly, so that'll be 0.5% per month, but it'll be in there for 48 months, so we get 54.0978. She's putting in 500 each month, ends up with 27,048. So she gets a little bit more. Tim's interests, though, take away what he invested. He invested 16 lots of 1,500, so there's his interest. Janine's interest, she made 48 payments of $500. She gets $3,048. So she gets, $150 more. You'll notice I haven't said a heck of a lot of questions on this, but